Okay, welcome to Chapter 6, Lesson 4, Dilations. This is our last lesson for this chapter. Alrighty, our learning target or objective for this lesson is to use scale factor to graph dilations. And our vocabulary for this lesson is none. There is nothing. Woohoo! Okay, moving right on then. We're going to go right into our key concept. Our key concept for dilations is a dilation with scale factor of x will be. Okay, an enlargement or an image larger than the original if our scale factor is greater than 1. If the scale factor is greater than 1, our new image will be larger than our original. A reduction or an image smaller than our original if our scale factor is less than 1 but greater than 0. Scale factor can't be less than 0, otherwise there is no image to do. Or if the dilation is the same as the original if our scale factor or k equals 1. If it's 1 to 1, it's the same looking picture. Okay, when the center of dilation in the coordinate plane is the origin, each coordinate of the preimage is multiplied by the scale factor k to find the coordinates of the image. Basically, you're just going to take your x and y coordinates, multiply them by the scale factor to find the new coordinates. That is when the center of dilation is the origin. Okay, let's take a look at some examples. Okay, a triangle has a vertices of 0, 0, 8, 0, and 3, negative 2. Find the coordinates of the triangle after dilation with a scale of factor 4. Okay, all you are is going to do, we're going to do A. Coordinates are 0, 0. We're going to multiply each one times 4. And that's going to get us our new coordinates. 0 times 4 is 0, 0, 0. A remains the same. It's going to be A prime. B. Our coordinates are 8, 0. Now we're going to multiply each one by 4. Give us our B prime, which are new coordinates. 8 times 4 is 32. 0 times 4 is 0. And C. C is 3, negative 2. We're going to multiply each one by 4, so 3 times 4, and negative 2 times 4. This can give us our new C prime coordinate, which is 3 times 4 is 12. Negative 2 times 4 is negative 8. And there you have it. There's our new coordinates for our dilation with a scale factor of 4. Okay, let's move on to our next example. Next example, we have a figure that has vertices 3, 8, 10, 6, 8, 2. Graph the figure and an image of the figure after dilation of the scale factor of of 1/2. That's 1/2. Okay, so let's graph our figure. 3, 8 is J. 1, 2, 3. There's J, which is 3, 8. K is 10, 6. At the end, 10, 6. And L is 8, 2. L is 8, 2. Okay, there's our original figure. Now we have to dilation a scale of half. We want to do half. So off the side here, once again, J, which is 3, 8. Multiply each one by half. That's going to get us 3 halves and 4. That's our new J prime. Let's look at K. K, we have 10 and 6. Multiply each one by half. And we're going to get a new K. It's going to be 5 and 3. You see we're just taking half the number basically over there. L 8 and 2, multiply each one by half. And we're going to get our new L prime is going to be 4 and 1. And we're just going to graph those points. So our first point is 3.5 and 4. So 3.5 is 1.5 basically. And then we're up 4. 1, 2, 3, 4. There's our new J. K is 5, 3. 3. That's K. And L is 4, 1. That's our new L. Graph those. And there is our new 1. Now to see if you did it right, you can always take a point from the origin and you should be able to go through your new point straight through your old points. Okay. Let's pretend those are straight. And that's how we do dilation with the scale factor of half. Okay, we have a real world example. Through a microscope, the image of a grain sand with a 0.25 millimeter diameter appears to have a diameter of 11.25. What is the scale factor of the dilation? So here they once again they gave you the input and the output. We're trying to find the middle. So we're trying to find the rate. We got to find a ratio. Okay, so we have our diameter of our dilation. Just a few letters there. Dilation over our diameter of our original, which is 11.25 over 0.25. If you just divide that out, our scale factor is 45. So you would take your dilation over the original and this divide them out, and that will give you your scale factor of your problem. Okay, once again, no example to finish up for class today, but you do have your graphic organizer, dilations, in your own words. And 3 characteristics. And that's give me draw one example and one non-example of a dilation. And this will finish up chapter 6, lesson 4.